it's reasonable. Okay, the way we look at this is that when we think about global warming, the number that's relevant there is the global average temperature. Okay, so that means we're taking temperature at all these stations all over the world, about 1.5 meters up.
Right.
And we're averaging them together with appropriate weighting, things like that, okay? And you plot that on a map, or you plot that on a time series. And, that's the sort of number that people are looking at when they're talking about, global warming, okay? And, of course, you see that global average temperature is rising. Now it's got all those little ups and downs, right, that we associate with the natural variability in the system, El Nino, La Nina cycles, right? Volcanic eruptions have effects. Even solar variability has a little bit of an effect on that, okay? But that's the sort of number that we talk about when we talk about global warming, okay? Now, okay, the thing is, no one has ever argued that every part of the globe warms the same rate, okay? That some regions are warming faster than others, okay? Also, there are some regions of the globe that might have cooling trends, even for, say, a decade or so, okay, or maybe even longer, okay. But these are all averaged together when you get that global average temperature, okay. And so, in other words, that regional stuff, okay, gets all averaged in together. But of course, that regional stuff, okay, that's the stuff that matters to most people, okay, clearly, right. And so, so you get these things in the blogosphere. Oh, those global warming guys are full of it because we've had a cold and snowy winter here in the northeast U.S. Okay, very typical. Okay, because it's confusing this sort of regional or local weather, okay, with the global pattern or the global average change that we're talking about. Okay.
Right.
And now, so then we ask ourselves, all right, so if you can have if we think about the global average temperature, okay, that's rising, there's some ups and downs on it, but now that we look at it at a regional scale, right, it can be a much more variable thing, okay? And such that, for example, right, the last 2 winters over the east have been cold and snowy, right? Okay?
Right.
All right, so what happens there? Well, what you're looking at is some kind of change in the atmospheric circulation, okay? That basically, you've got this cold Arctic air plunging down, clearly, because that's exactly what's happening, okay? And that gives you a temperature contrast, and that's what gives you the storms, okay? So it all kinds of fits together, okay? Now, in terms of, local weather, that's just weather, okay? It's a very chaotic sort of thing, okay? And, we can talk about, weather from day to day or week to week, but even we know that, as, out in the east or whether it's out here in Colorado, you might have a few strings of winters that are colder than normal, followed by some real warm ones, right? Sure. So there's some different time scales to this, okay? All right, but now the question being asked here, okay, is there something about the weather, this crazy winter weather that you're getting here, okay, that might be kind of forced by something, okay? Is there something out there that's changing, okay, that might actually force the big-scale weather pattern to give you that, cold stuff out in the northeast, okay? And this is where this Arctic stuff comes in, okay? What's happening in the Arctic comes in, right? So what happens, of course, is that, think of it this way, is that, okay, we know, of course, the equatorial regions get heated by the sun more strongly than high latitudes, okay? That's why it gets colder as we go to the north, obviously, okay? Now, that also gives us a temperature gradient in the atmosphere. In other words, if we look not just at the surface, but in the atmosphere, it gets colder as we go north, okay? And that's what gives us our, basic large-scale atmospheric circulation. In other words, here in the mid-latitudes, we live in the area of westerly winds. Okay? And the westerly winds is because we've got this latitudinal gradient in the atmospheric temperature. Okay, so it gets colder to the north. Okay. Well, all right. Now, what we're doing in the Arctic is, as we lose the sea ice, we actually start to change that temperature gradient. Because because, all right, yeah, it gets colder to the north, okay, but now by losing the sea ice, you actually start to pump some ocean heat back into the atmosphere, okay? And so the question out there, okay?
By the melting of the ice, or heat?
No, okay, yeah, let's go through it. Yeah, it is by the melting of the ice, but it is a seasonally delayed thing. Here's what happens, okay, and here's what a lot of people get really screwed up on, and it's pretty straightforward, but all right. So it's getting warmer, okay, and what is happening is that we're not growing as much ice in winter as we used to be. We're melting a heck of a lot more in summer than we used to, okay? So now what happens now is that if we look at the end of summer, end of the melt season in the Arctic, September, say, okay? And specifically September, what you find is that there's much, much more open water than there used to be. Okay? But what has happened is because that open water is very dark, it's been absorbing a lot of solar heat through the summer. Okay? So what happens now is, okay, it's picked up all that heat through the summer, through those open water areas. So now, of course, the sun sets in the Arctic, of course, in the winter, right?
Right.
So now you've got this ocean with all this heat in it that it didn't used to have, okay? Autumn comes, the sun sets in the Arctic, that heat gets released back to the atmosphere, okay? And so what's happening is the atmosphere gets warmed because the ocean is losing its heat back to the atmosphere. That's why you get this big warming in the Arctic in the autumn and through the winter, okay? Because it's releasing that heat back, okay? So you say it's related to the ice melt. Yes, it is, but actually there's a seasonal lag to it, you see. It's actually, the ice is melting in summer, exposing all this dark open ocean, picking up all this heat, and then autumn comes, the sun sets, that heat's got to go back to the atmosphere, and that's what it does. And that greatly warms up the Arctic relative to where it used to be. Okay? In other words, relative to, say, where we were 30 years ago. Okay? And what's happening is that is starting to change the sort of basic temperature gradients in the atmosphere, okay, that I talked about before.
Right.
And so if you do that, okay, the thinking is, okay, that could actually let this cold air in the Arctic kind of start to spill south, okay? Now, you say, well, hasn't the air been warmed? Yes, it has. Okay, it's still cold air, though, right?
Right.
Right. But, that's the thinking. The thinking is that to put it another way, we've put it now a heat source in the Arctic that there didn't used to be. And if we do that, the thinking is the atmosphere, the circulation of the atmosphere responds to that. It feels that heating and responds to that. And one possible outcome of that is you get this sort of pattern that you're seeing here for the last couple of winters, okay, that you've had cold and snowy over the eastern U.S., especially over in Europe, okay, but at the same time, this extremely warm Arctic. So it's a funny thing, because if we think about, that's basically it in a nutshell.
So could you say, basically, the polar vortex, this circular cold air pattern, has been disrupted, and it's sort of
exactly
south? Okay.
Exactly. Yeah, and that's what we kind of try in our write-up. Okay, we try to get it into a fairly understandable state, but it's a bit of a difficult thing to get one's arms around. But yeah, you're right. It's that polar vortex gets disrupted. Now, I'm saying this. Okay, when I say this, gotta stress here that there is no real smoking gun here yet, okay? This is something that there's a lot of work on right now in the scientific community, asking this question. Now, this whole notion that, if we start to warm up the globe, global warming, that we can get actual changes in atmospheric circulation resulting from that. There's nothing new there. Okay, no one has ever argued that this is just some kind of a straight linear thing that everywhere warms up the same and nothing else changes, right? We've long realized that as we warm up the globe, we're going to have things like accompanying changes in patterns of atmospheric circulation. circulation, okay, which might exacerbate the warming in some areas. It may go against the general warming in some areas, at least temporarily, okay? That's no surprise there. There's nothing new about that, okay? But what we're seeing here for the last couple of winters, it's one of these things that it's got, in terms of the science community, it's got people thinking about this, okay? Could there be an Arctic source to what we're seeing now, okay? There's some physical reasoning behind this, as I've talked about, okay? There's evidence from this from climate models that such a thing can happen. There's some limited observational evidence for it, okay? But no one has the answer yet, okay? This is very, very much in sort of it's cutting-edge stuff. No one really knows for sure. And so, we really need to look at this problem a lot harder, and we need to see is this pattern going to continue? This funny winter pattern are we going to see it next year? Are we going to see it next year? Right? Those are the sort of questions we're asking.
Assuming that you guys were onto something, and this is exactly what's happening in this part of this larger system with moving parts, obviously. If that cycle continues of melting more ice than we're growing over the winter, eventually it would be basically the dark water would take on even more and more heat, and it would sort of accelerate over time.
Oh, yeah, there's a feedback there. Yeah, I mean, we're going to lose, okay, as we move through the years, okay, we're going to be losing more and more of that summer sea ice, which means we're going to be picking up more and more heat during summer, which means we've got that even bigger and bigger heat loss back to the atmosphere in the autumn and winter, okay? So that's going to continue, and it's going to get stronger, okay? But if you ask the question, well, does this mean that we're going to now stick ourselves in this funny winter circulation pattern we've seen the last 2 years? That's not clear at all, okay? Maybe this is a transient thing that we're seeing. Maybe it's that at the state of the sea ice cover that we see now, this is the response of the atmosphere. Maybe 20 years down the road it changes, okay? We don't know.
Okay.
In other words, what I'm saying is just getting rid of more ice, okay, doesn't mean that winters in New York City are going to become colder and snowier with time. It doesn't necessarily mean that.
But it could.
Well, yeah. I mean, yeah. I mean, the speculation. As the scientists, of course, we're very circumspect about these sort of things and love to couch these things in uncertainty because this is the thing we damn well don't know. We just don't know. But it is very interesting stuff that we're seeing. And it's one of the things that's got people in the science community scratching their heads and thinking about it. It's a fascinating problem.
Is your caveat more that you don't have enough observational evidence, or more that it's part of such a large, complex system that we can't assign blame just to?
I would say it's both. I would say it's both. We don't have enough observational evidence yet, and it's a very complex system, and to tweak the effect of the changing sea ice cover out of all these other factors, like El Nino, La Nina, okay, can be very, very difficult. So I would say it's both.